having discussed or having treated the concept of resonance in an AC circuits or RLC circuits when such components are connected in series. Now, it is important for us to know the applications of resonance in electronic components or electrical components. But we are going to concentrate on electronic components such as radio, television, and so on and so forth. Now, the first thing we should understand in such gadgets, there are various components as capacitors, various components as inductors, various components as what? Resistors. But the resistors are concerned with consuming and resisting some amount of power. But what about the components such as capacitors and inductors? What do? They are there to interact and give rise to resonance. And that is why we calculated the value of resonance as XL equals to XC, which we say this is 2 pi F of naught, and this, that is L, and this is 1 all over 2 pi F naught C. We ended up in our last lesson or previous video or previous class, we ended up in our previous class to calculate that resonance is given as 1 all over 2 pi roots LC. It occurs at this point. The diagram is still on the board. But our concern today is to find out the applications or where resonance is applied in an electronic circuit or in electronic gadgets such as radios, televisions, just name it. Even radar. You don't know that resonance is applied in radar? Of course, signals. Anything that has to do with signal goes alongside with resonance. Because there must be a point of intersection between the tuning gadgets and the incoming radio signals. By the time there is intersection, maximum current is attained. Resonance occurs. Resonance occurs immediately. Maximum current is attained. So let's see. So the first application is in radio. Radio, gadget, electronic we always have at homes. Radio, that's the first one. You tune radio. You continue to tune frequency, searching for frequency here and there. You continue to hear the sheen sound, shh, everywhere, because there is no intersection of incoming frequency with the gadget you are holding in your hand. The very moment there is an intersection between the incoming frequency and the gadget, the electronic gadget such as radio in your hands. So the first one is radio. Okay? Once there is intersection, maximum current is attained. And once maximum current is attained, resonance occurs. So that's number one. Number two is television, TV. And various television systems, whether small or big or whatever, you have resonance there. The same thing happens. You continue to search for channels. You continue to search for channels. Here you search for signals. On the radio, you search for signals to have an intersection between incoming radio signals and the radio signal from the one you have in your hand. Then we search for channels. We search for channels. Around television, we tune, use a remote control and search for channels. Why are we doing so? Because we already have the TV in our home. We are looking for external signal where there is an intersection. And that intersection, once it happens, maximum current is attained, resonance occurs. That is what happens. So what about the third one? I don't want this video to be long. Oh my goodness, this is interesting. Then what happens here? I repeat, you continue to use the remote control, searching for channels of different types. Different types. You continue to hear the sheen sound from the television set. Even the screen will not show anything because there is no intersection of the incoming signal or frequency with the one at home. Once there is an intersection, maximum current is attained. That's why there is an intersection. At that point of peak current, there is a corresponding radio frequency. That is F0. You have it. It connects. You have your channel on. That's what happens here. And then the third one is what we call radar. Radar, R-A-D-A-R. Of course, we use this in airports. At our various airports, you have radar. It gets communication from distant objects. It's a gadget that gets communication signals from distant objects. The incoming airplane and the outgoing airplane to avoid collision. Why? Because it must get signal from the incoming one and then know the direction where the signal is coming from, interpret it to avoid collision. That intersection has to do with resonance. It happens in various airports. So this applies here as well. Where else do we apply resonance? If you know any other place or any other thing where the applications of resonance find very importance, put it in the comment section and let me know when we discuss it together. I don't want to waste our time. The topic is just applications of resonance in RLC series circuits or electronics gadgets. Take note of this. Can you give me number 4 gadgets? Can you give me number 5 gadget? Can you give me number 6 gadgets? Where else can we find resonance? I think there are other areas we can find resonance. Any area that use inductor and the capacitance or capacitor. Can we find resonance in GPRS, global positional remote system? Can we find resonance in satellite dish? Can we find resonance? Check if we can find resonance in GPRS. Check for me. Check if we can find resonance in satellite dishes around, satellites, dish, and so on and so forth. Check if we can find resonance in all these. I stand to be corrected. If this is not correct, put it in the comment section and I'll stand to redo this video for our learning pleasure. Check, I say check. Check if we can find resonance in GPRS. Check if we can find resonance in satellite, dish, and whatever. Check also if we can find resonance in a gadget such as all these antennas and so on. External antennas, outside antennas, etc. This is not an assignment. I want a collaborative work. Let's collaborate and see where we are right and where we are wrong. Thank you so much for listening. And then put your desire, your concern in the comment section. Give me some thumbs up. And then put on the bell button for constant notification. Do not forget to share with your friends, network, and students. And make sure I check it out. Oh my goodness. All right. Okay.